Welcome, engineers. My name is Travis IQ, and today we're talking port address translation and port forwarding. Useful technologies. Let's get into it. Port address translation, also known as PAT, and an accompanying technology, port forwarding, are pretty important. They are subsequent technologies to the core, which is network address translation. That is the first video that we published. If you haven't seen that video, go back and watch that one before you watch this one if you're not as familiar with that technology. If you are familiar with it, join me in the void as we discuss port address translation and port forwarding. So, network address translation, we said, at its core was a one-to-one mapping across the router. NAT. When I come in with a source address of 192.168.1.1, I leave with a source address, if this is the inside interface and this is the outside interface, I leave with a source address that is globally routable, 204.24.18.11, for example, and everyone sees me in the internet as this source address. This is address translation, and it's conducted through an address translation table. And then your first question may have been, Travis, and there are some other mechanisms that we can utilize for the static address translation or some dynamic translations or things like this. But your first question might be, well, what happens if I have a bunch of addresses in here, right? .1, .11, .104, .17, .22, and I'm a small office or a home office, and all I have is this one little public address. I just have one public address. So what happens? This just gets mapped here, and then the rest of these hosts can't get out? Then you would say, well, Travis, do I get multiple public addresses? And I would tell you no. So I don't get 204.24.18.6 as well. I don't get that. So I need to map multiple internal addresses to a single external address, many to one, right, or one to many. The term in the Cisco world and in the world at large, if you wanted to use it, would be NAT overloading as well. So this would be called overloading NAT overloading, or NAT overload. And specifically, the way that we do this is we use an IP address port pair, right? This is a pair of 192.168.1:63428. This is called a socket pair. And we use this pair now to identify this internal host. You say, okay, Travis, well, I need to use this pair to identify the internal host. So that means that I also need to know which port is associated with which host, and that is correct. And so now, if we start using port address translation, I'm actually going to give myself a little bit of room up here. If I start using port address translation, I actually need some additional information in the table now, because I need the port to help me identify that internal host. Because why? Because I wouldn't know who it was if I was just using a single external address. So if I use the .1, .14, .104 hosts in here, and they all are on this LAN communicating through R1, and they're all using the external address 204.7.19.8, when these hosts communicate out to a bunch of different servers, right, Google, some other mail server, and an FTP server out here. So we've got POP, HTTP, and FTP, a bunch of services out here. I'm just listing application services or destination ports as well. When these hosts are communicating out, I'll use some different colors here to identify. 14 and 104, when they're communicating out to those servers on the internet, when those servers communicate back, who are they communicating back to? They're communicating back to this address, because that's the address that they see. When we were talking about this in network address translation, we said this is the address that all of these hosts see. So when every response packet comes back to R1, it's all coming back to the .8 host, 204.7.19.8. And the router sees this and goes, who do I send this to? Because I know, well, it may have it won't have a translation because it's not a single translation, and so it knows it's going to have to send it to internal hosts, multiple internal hosts, and it's not going to know which one to send it to, because it's going to need to have multiple mapped hosts to this one IP address here. And so what we need to do then is give it some additional information. And so we need to amend the table to include some additional info here. And in fact, we do. This is now a port address translation table, a PAT table, or NAT overload, or a NAT table that includes overloaded information. And so what we have here now is, let's say this is the 192.168.1 network. Then we have the internal hosts and their port numbers. And we have the external address and port number and associated port number. So in here we have 192.168.1.14 with a port number of 62168. And it's going to be mapped in this table to the external host 204.7.19.8 with an external port number of 62168. Why did I choose the identical port number to the random high port that this internal host chose? The reason I did that is for a specific reason, and that's because when you configure NAT overloading on a Cisco device, we talk about Cisco devices in here a lot. I teach a lot of Cisco equipment. When you configure this on a Cisco device, the Cisco device actually uses by default the internal port number of that host. Now, that's not necessarily always the case. If you were to have an overlapped port number, if the next host were to choose or were to have assigned a random high port on that exact same port number, 62168, which you can do, not 14. I made a mistake here, didn't I? Not 14, it's a different host. 104. You can't do that with the same host. That would be identifying the same service on the same host or a different service on the same host with the same port number. You can't do that. But I can do this. .104 and .14, they just randomly assign the same port number. The likelihood is low, but it's possible. And so this is the default behavior in NAT overloading environments on a Cisco device. In this case, if I were to have a different unique host using the same source port, which they could use because these are just ephemeral ports, then the external address that I'm going to use to translate it to actually has to be a different port number. And that port is going to be the next port up in the Cisco world anyways. We could do this differently, and different network operating systems, NOSes, do this differently. But in this case, this is the default behavior that we're going to use, and I like this behavior because it does make a whole lot of sense. Finally, I will give you the example of another host in here. Let's call this the .11 host, 192.168.1.11, and this host uses an internal port, a random high port of 58923, and this is going to get mapped to 204.7.19.8 with a port number of 58923. And now you can see that port address translation now allows us to map one external address. This is all the same external address that has been given to me by my ISP, or however they're doled out if I've requested it specifically a static address from the ISP for a business or something like this. Maybe it's not dynamic, but either way, I have this single address, and it is mapped to multiple internal hosts, the .14, the .104, the .11. If this host were to establish multiple connections across this router, 192.168.1.14:63928, I have to also forward that traffic to the appropriate internal port, because part of that traffic needs to go here to this port on this host. Part of that traffic needs to go here to this port on this host. I actually can add an additional mapping here, and in fact do 204.7.19.8 63928. So this is also valid. If you were to have a different service communicating out to the internet, right? You're running Google and Proton Mail and a video game or something like this, and they are all communicating, and they have to have a unique port numbers to identify those services on that internal host. Then I have to also establish a unique mapping for those. And so this is what a port address translation table looks like. This is a very useful utility and is put in place all the time in these small, medium environments, in larger environments as well, but then you're going to have to add some additional utility because you can't just map a single external address to a bunch of internal hosts because you're going to have too many internal hosts in that case. We will go over that in a more commercial discussion, but for now this is sufficient. There is one other piece that I wanted to talk to you about, and that is, what if I had an internal host here that's waiting to be communicated with? It's not establishing a communication out, but it is a service internally that I can access. For example, a Plex server or something like this, or in my case, I like to use the example of automation services, either home automation services or business automation services like an automation server or a repository of video or picture information or files or things like this that I want to be able to access remotely. And so if I have this host here, let's say this host has an address of 192.168.1.47, and it's listening on 8080, a well-known alternate HTTP port number. Do I have to use 80 for HTTP? I do not. I could actually use any port number. But then the problem is do I know which host I'm communicating with? Does that host know that I'm sending HTTP information? It depends. So maybe a discussion for another time. But so I listen on port 8080. But how is any host out here going to get to me when there is no mapping here? 204.7.19.8. And if I come in with a destination port of 8080, do I see a mapping here in this port address translation table that I've just built based upon those external connections that have been made? I do not. There is no mapping here. R1's going to go, oh, geez, I don't know where this thing goes. I don't have it in my table. And guess what? The routers only know what's in their table. So this adds an additional layer of complexity. Port address translation does, PAT. And there's a service that we utilize to combat this, and that is to allow us to forward this port to this internal host. And you'll never guess what it is called. It is known as port forwarding. Maybe you've configured port forwarding for a video game or some other internal service or something like this where they told you to go into your router and do this, and you didn't really know what was going on. This is what it is. What you're telling it to do is forward this port to a specific internal host. What you're doing is you're adding a mapping for that router to forward it to a specific internal port. And so what I do is if I add a port forwarding configuration, and it's different for every GUI, right, for every graphical user interface and network operating system, but if I add a port forwarding entry, what it's actually doing is it's adding an entry to this address translation table. So 192.168.1.47:8080 is now mapped manually via port forwarding. You have to put this mapping in to 204.7.19.8:8080. So when I see now 8080, I forward it to this internal host. It just can't be built dynamically because there's no information for that router to pull. And so now we've started to pull together a lot of critical information to actually make these systems work. We established what network address translation does in terms of actually changing the header and breaking IP end-to-end connectivity, but also giving us a mechanism of obfuscating the internal hosts, as well as saving address space back in the day. And then we said this is the additional service that allows us to map a number of internal hosts, multiple internal hosts, to a single external address. Furthermore, we then said if an external host tries to communicate to those internal hosts, we can add a mapping to allow that external host to be directly forwarded to that internal host via port forwarding. Some really useful technologies. We can continue to elaborate on this from a commercial standpoint at another time, but I think that's sufficient. As is always the case, engineer, break stuff, have fun. We'll see you next time. Let's go.